do that. Ah! Can you hear me? Oh, yay. Okay, let's see if I can get this going. Hey, Ken, I think I broke this. It's just got dashes on it. I can't see anything on the screen. Help me. Oh, shucks, there it is. Okay, here we go. Hey, guys. Okay, welcome to the February monthly meeting. A big thank you to Gwinnett County for hosting and presenting today. What about a hands down for this facility? This is great, right? Let's give it and then also thank you HNTB for sponsoring and for the lunch. Another? Yay. Thanks, guys. A couple of reminders before we start. So just a reminder, the Southeast Summit is in March, so we will not have our monthly meeting. Please register a sponsor if you guys have a chance. The registration is still out for that. It's March 22nd through the 25th in Charlotte, and it's going to be all of the states in the South. Our next monthly meeting is going to be April 22nd at Sandy Springs City Hall. We're going to have Sarah Hall for the Rivian project, and Temple will be our sponsor for that one. If you guys are interested in going to the ITS America conference, it is in Detroit, June 9th and 12th, if anybody just has a hankering to go to Detroit. And then, okay. Our 2027 conference, y'all, we're coming back to Georgia. We're doing Callaway Gardens. Greg Ramsey is going to be our lead for that conference. It is going to be September 12th through the 14th in 2027, and we are currently doing a call for conference leads or committee chairs. If you guys are interested in helping on that with Greg in September of 2027, email anyone on the board pretty much. We can get you to the right place. So membership registration is open right now. I know a lot of you have already registered. If you sign up and you can't get your pull down on the registration, it means your membership is not paid. Kate Sheeran is the chair for membership this year. So if you guys have any questions, just email her or any of us on the board. We also are opening board of director nominations and award nominations. We're leaving them open all year round. So QR code on here if you guys know anybody who wants to run for the board for 2027. We have 6 directors who are rolling off of the board. And then if you know anyone in the industry for award nominations, we will please submit all the great awards for the nominations that are going to be the November meeting at Maggiano's to present those to people. So once again, the ITS Summit, that's March 22nd to 25th. Registration is open, and I think that's it for me. Matt, I think, oh, thanks for that picture. Do you want me to smile and not look like I'm eating a hamburger? Okay. Oh, great. Okay, Matt's gonna come up here, and you're not done with him yet. Legislative, got this.
Got it. So quick legislative update, a few of them. One a little bit spicy is apparently there's a few pieces of legislation that have been introduced to adjust the way that the GDOT commissioner and the GDOT director of planning are appointed. Don't know where that's going, but just a little spicy. Thought that you might be interested in that. But I think more interesting, both to our consultants as well as our local agencies, is that there's legislation that was introduced last year that's been reintroduced that would require qualification-based selections for engineering services. A lot of you already do this. But many agencies do not, meaning that they just go with a low bid or they go with someone that they like working with. So that's up for debate. Again, that's caught a lot of traction from last year, and it's a hangover. So just to make you aware of that, that is out there. If you want to voice your support or lack thereof, please feel free to contact your legislator.
Thanks, Matt. There's the stairs. And with that, I'm going to pass it to Andrew Park for his presentation for HNTB.
Hey everybody, Andrew Park, Traffic Engineering Department Manager here in the Atlanta office. Happy to sponsor today, give you a little bit of insight and background for HNTB. So we're an employee-owned company, 100% That's where we've been for the long haul here. That started about 2000, and that's how we grow. That's what we focus on. Ultimately, our successes on projects and working through that as an employee owner is a great benefit to be able to make that impact. So I don't know, hopefully everyone can hear me. I don't know if I'm too tall for the microphone, but no, not at all. But wanted to highlight some of the awards that HNTB as a firm has been recognized recently. So just a large list here and a lot of different specializations. HNTB is an infrastructure solutions company, so that doesn't necessarily just stop at traffic or anything else, or ITS in that space. And you can see some of the bridge-related and everything else in there. WTS Employer of the Year as well, and Iris Ortiz is heavily involved with WTS this year, so great to get that recognition. Talking about HNTB culture, HNTB vision and the leadership characteristics are what we as HNTB employees live and breathe every day. It's a great way to communicate and ultimately build your own career and drive your success. So the different leadership characteristics, there's 17 of them. It really just gives a great way to have that conversation and what you're focusing on now and how you apply those to projects. That's a great way to not only talk internally, but also with our partners. So our culture here in the Atlanta office is the same across the company. So it's a great way to build our brand and vision in that space. Communities, wanted to highlight that too. Our team here locally, we've been heavily involved with some of the STEM outreach program, as well as introduce a Girl to Engineering Day, some of the other initiatives, and also giving back social responsibility and working through really just being present. We're not just engineers and folks working on projects, we're also involved with our communities, making sure we're doing that benefit in our backyard and seeing those improvements for those folks. That's what brings us, and a lot of us here in this room, to the infrastructure area in ITS. HNTB has been around for over 100 years, about 60 or so in the Atlanta market. We cover a lot of different services. So like I said, infrastructure solutions. In addition to all these that are listed, the architecture is a highlight too that is a little bit out of my day-to-day, but we do see a lot of input on different sporting arenas and venues that we're the architecture company that is really delivering those products as well. So it's a cool niche as well that get to see some of the the Las Vegas Allegiant Stadium, as well as where the Super Bowl was this past year. HNTB was heavily involved. Clients are, and our partnerships, I mean, those are long-standing. They're very critical and important to how we continue to grow and build and just benefit our communities. So with that, talking about our ITS, Traffic Engineering and Technology team, it's a mouthful for what we do here in the Atlanta office, but there's 30 or so members of our team here. We support a lot of our different clients. So GDOT across all of our different offices, plugged in there, boots on the ground. Really just continuing to build that partnership is great. GDOT District Offices 1 and 6 is something that we've been supporting recently this year. Gwinnett DOT, happy to be here and support and talk through that as well. And then City of Atlanta, Cobb, and then also our team has a big input on MMIP program management consultant traffic support between GDOT and TDOT areas, as well as MARTA listed. Our services, just to give sort of what we're doing with our clients, traffic engineering, a whole broad spectrum with our group of 30 professionals, a lot of expertise in that space between forecasting, analysis, design, safety, signal timing, and noise modeling. CV and V2X, Kamari's here, she's heavily involved in that program, as well as Michael. ATMS and ITS design, we're really touching a lot of the areas, just building up with our clients and focus in that space. So you see some of the other specializations that we touch on, but really diverse group. Happy to have a broad impact on that, but that covers it for most of my slides here today. Thanks for coming, and looking forward to the presentation.
Okay. And with that, I'm going to introduce our speakers. Joshua Brown graduated from the University of South Alabama in May of 2018 and began his engineering career with Jacobs in the metro Atlanta area. During his time there, he worked on a variety of transportation projects, including RTOP and signal operation initiatives. In 2022, Joshua joined Gwinnett County Department of Transportation's Traffic Management Division. Since then, he's been involved in traffic signal optimization and operational studies for Gwinnett County's 785 county-owned traffic signals. That's a lot. Wow. Okay. Josh is like, yes, it is. He has also contributed to the evaluation and testing of intelligent transportation systems and data-driven platforms to support both planning-level analysis and real-time operations. Joshua is proud to be part of the collaborative and forward-thinking team focused on improving safety, efficiency, and mobility for Gwinnett County residents. Outside of work, he enjoys training Brazilian Jiu-Jitsu, that's a hard word, completing his master's degree and spending time with his family and friends. And then also Jerry Oberholtzer. Jerry serves as the Director of Transportation Planning for Gwinnett County Department of Transportation. He leads strategic initiatives focused on safety, innovation, and data-driven decision-making across one of the fastest-growing counties in the country. Jerry has been instrumental in securing federal, state, and regional funding to advance new technologies that help solve long-standing transportation challenges, including Gwinnett's federally funded SMART grant program project on Singleton Road. He is a lifelong Gwinnettian and a proud Clemson graduate, so he believes in long-term planning, bold moves, and wearing orange with confidence. So I'd like to introduce both Jerry and Josh. Thank you.
Looks like I'm going first here today. Y'all are very brave inviting a planner to a meeting of engineers. There is, as you know, nothing more detrimental to your scope, schedule, and budget than asking the planner, what's your idea? What do you think? So we're going to talk about the Singleton Road Corridor Technology Improvements Project, which is based off of the SMART grant. The SMART grant is a program that came out of the IIJA or the BIL or whatever we're calling it for this week. About 4 years ago, and the really interesting part about this grant is that it's a 100% funded grant, so there's no match requirement. And really the purpose of this grant, the federal government wanted you to try things you've not tried before, things that may actually fail. They wanted to give essentially that safe space to try technology, to try different things, and do something your community probably wouldn't do on its own. So we looked at the NOFA, we looked at where we think in Gwinnett this could be particularly useful for. And we looked at Singleton Road. Singleton Road's had a couple of major incidents over the last several years. And we've looked at Singleton Road to see what can we do to improve this corridor. It's your typical 5 lanes, 2 in each direction, center turn lane, a mile or more between traffic signals, residential on each side. A lot of people just crossing the road, not a lot of mid-block crossing options out there. So we wanted to find a way that we could be more reactive to crash response. Instead of being reactive, we wanted to be proactive. So we wanted to find ways that we could add to the already building cases that we were the already projects that we were already working on out there to improve safety. And for those not familiar with Singleton Road, essentially it runs between Jimmy Carter and Indian Trail. A couple of traffic signals there in the middle, but in general is a long stretch of 5-lane roadway. So as I stated, essentially, this was a corridor that has a long-standing history of safety issues, underserved population out there. again, that SMART program really wants to support the demonstration projects to improve safety and efficiency, and we thought this was a great idea for this area. The SMART program is broken up into 2 different stages. Essentially, stage 1 is focused on planning, prototyping, and evaluation, and then stage 2 is scaling, taking it, getting more money, and doing this essentially county-wide. So this wasn't a greenfield test for us. It was really layered onto a real corridor that had some real constraints. So step 1, as always, is understand the problem. So first, pull the data you already have. So we looked at our crash history and pedestrian incidents out there and came up with a heat map as far as what's going on out there right now. Second part is to go talk to the public. One thing I think we get wrapped up too much in is just throwing things out there to see what sticks. Before we did that, we actually wanted to talk to the public and make sure that the data we had collected from the already available sources is what they agree with. They're like, yep, those are problem areas. Those are areas that we feel dangerous walking across the road. These are areas that people are trying to get to. Understanding the data jives with what the community sees, and then also get some feedback from the community on what do you think the solution is. So once we ran through that, we really started to get into the technology. Let's put some technology out there and actually do some real-time data collection along the corridor. We wanted something that we could have continuous data at both our signalized and unsignalized locations. We wanted to be able to justify where we had mid-block crossing needs, where we needed to prioritize our investments. We wanted to look at software and hardware that could detect those vulnerable road users without requiring anybody to push a button. We wanted to make sure that we had technology that would work in low light, complex roadway environments, and we wanted to make sure that this was scalable, something we could do corridor wide. So some of the ways we collected data out there was we used 2 different types of sensors. We used the OmniSight fusion sensor, and you can see here an example of essentially how it's tracking as people are crossing the road in these different areas. We also use Viva sensors, where we could look and again see where people are crossing the road, where people are walking along sidewalks. And the great thing about these sensors is that they can go from data collection to actually being repurposed to be part of our solution. So a couple of videos out there, you can see really what we were looking for was the near misses. I don't know how well you can see on here, but essentially, these are issues people told us was happening out there, but now we actually have it on video to actually see where people are crossing the road. Here was a crosswalk with people driving essentially right behind the pedestrian as they were crossing the road. Another one here where we had somebody riding their bike essentially right down the side, and the sensors are picking up and essentially tagging and saying this is a near miss. And then here, this is a good one. This is essentially this person almost got hit on their bicycle crossing the crosswalk in this area. So again, without these sensors out there, we're just going on based on what people tell us. And this was really the first time we really had eyes on what was happening along this corridor. So then the second step is to go deploy technology, figure out exactly what we wanted to have out there and how we wanted it to operate. Again, we wanted to make sure that this was going to be passive. We didn't want anybody to have to press a button. We wanted to make sure that this was going to detect people out there. We wanted to have ways we were going to alert drivers. We wanted to look at ways our signal timing and operations could be adjusted to improve safety out there. And we wanted to make sure that we kept these sensors and other data collection hardware items out there so that we could continuously evolve this system. I told people, and people ask me, what is this going to do? I would say, well, you know how you'll see on roadways, you'll see the diamond sign that shows there's deer in the area. Now imagine instead of a deer, it's a human, and it actually lights up when there's actually a human in the area. So that is really what we were looking at to try to do for this corridor. So we sat down, we had a kind of great brainstorming session where we talked about all the different types of hardware options that were available for the corridor, and we ended up settling on the pedestrian warning signs, smart street lighting fixtures, and then connected vehicle messaging at 2 of our intersections. And we'll start to talk about that enhanced pedestrian warning signage. Again, this is the signs that actually is going to light up when our sensors detect there are pedestrians in the area that are crossing the road. Now, the interesting thing about this is we wanted to make sure that while we made it safer if they cross the road, we didn't want to encourage people to cross the road. And so that's going to be something that we're going to look at as we continue on with this project and see, are we actually now encouraging more people to cross the road because they feel it's safer because now drivers are warned about their presence. But essentially, this pedestrian signage out there, like I said, doesn't rely on pedestrians to press a button. It gives drivers early awareness of people crossing the road. These ones can be solar powered, and so they can be reliable. There's plenty of shaded areas along this corridor as well, so ensuring that it was low power operation was very important. And we wanted to make sure that this would be scalable without any major infrastructure changes, so this was really plug and play. So an example of where we put this out there is Singleton Road at Sugarwood Lane. Essentially, you can see, I don't know if you can see real well in here, but you can see the arrows are where we put those warning signs up. And then you can see in the middle where the Omni sensors are that are actually looking for people in this area. Now, as far as the street lighting, we went with the Jugano lighting system. And these are also plug and play. They go on your existing Cobra head poles out there. These are multifunctional and can be used for a lot of different things. So they have capabilities to detect audio, video, other environmentals such as weather as well. They can be highly integrated with all of the different systems we already have in place in the county. Again, it doesn't rely on pedestrians to push a button. It detects a pedestrian and can turn on sort of a high beam light that can help illuminate the sidewalk, help illuminate the road, giving both drivers and pedestrians a better sense of awareness along the corridor. And again, it's another one of these things that can be really scalable, not just on the corridor, but throughout the county. So we installed several of these closer down towards Jimmy Carter, which is this area is the more commercial side of Singleton Road along the corridor out there, and again provides that high visibility, and we're able to track, and we're very interested as we see, especially as the time changes here when we have daylight savings time coming up, to see how this lighting affects pedestrians and safety out along the corridor. Signal operations, now again, I'm not the engineer, so I'm not going to get in the weeds about how we adjusted our signal operations. We've got Troy here from 360 Network Solutions, who is our partner on this project, so if you have detailed questions about those, you can talk to him. But essentially, we looked at things like the leading pedestrian interval. We adjusted our flashing yellow arrows, and also installed the accessible pedestrian stations for disability access along this area. Essentially, it's just a mix of things that are already being done around the region, around the country, and we're honing it in to be part of this overall process on Singleton Road. So again, these are the corridor-wide modifications that we've made, and it's always going to be a work in process. That's the biggest thing to understand about this, is it's not, well, we said it and it's going to work great, we don't have to do anything else with it. So step 3 of part of this grant was to essentially evaluate and iterate as you go forward, to look at real-world conditions. This wasn't a one-and-done installation. We've tested everything in real-world traffic conditions, with actual pedestrians, buses, turning vehicles. I think one of the things we learned off the bat is that calibration matters, that our detection zones, our sensitivity, signal timing, all that has to be adjusted. And once you think you have it right, you got to go back and adjust it again. So even though this grant performance period ended in December, we're working with 360 for the next couple of years, really, to ensure that this system continues to be tweaked and we change our models as necessary. This really is an operational pilot more than it is a technology pilot. And so, we had to work very closely with our operations staff, Kristen and her group in traffic signals, because again, I'm not the traffic engineer, and so they don't want me touching anything, so I let them figure it out, just tell them what we're trying to do, what we're trying to accomplish, and they've been big partners with us to make this work. So our lessons on this, what we learned that worked out there essentially is that it's going to be a mix of solutions and not just one, that it is, it's not just one piece of technology that is an end-all be-all. The biggest win really was visibility, that we have the passive detection out there, and it finally gives us a clear picture of how people actually cross in the corridor, and not just where we have the crashes already happened. That's really been a big key for us, and we're very excited to watch moving forward how things adjust with the system in place. The targeted treatments we did out there really have made a difference, and the data that we've collected has been invaluable for this corridor, because there's plenty of other corridors around Gwinnett that are very similar to Singleton Road. So some of the big picture lessons we learned out of this is that first off, integration with our current infrastructure is critical. Gwinnett County has a robust fiber optic network. We already have cameras and other technology in place. So we wanted something that was going to work with that, something that could be integrated into our system. It was very important as we looked at technology solutions that we found those particular solutions for that. Data management and calibration, they do take time, and it's a continuous working process. Stakeholder coordination matters, because ultimately if you do a project and the neighbors don't think it's going to work and they don't see the benefit in it, then we really haven't solved anything out there. And this is a community that's been screaming for improvements along this corridor for a long time. So, and in fact, a new county park has just opened up along Singleton Road. We know that's going to change how pedestrian movements are in the corridor as well. So it's an ever-changing scenario out there on Singleton. So flexibility really is key for what we're doing. So the main takeaway really is that deploying smart technology is as much an organizational and operation effort as it really is a technology one. So moving forward, this pilot really created a roadmap for scaling the smart corridor deployments across the county. We're really excited about other opportunities. Now, unfortunately, with the SMART grant, they have reallocated the remaining funding. So there was $200 million left in the program. We were hoping that there would be one more year left, but Congress has reallocated that somewhere else. But this is technology that can be funded either locally, there's state, and there's other federal opportunities such as Safe Streets for All as well that could potentially fund this type of technology integration in other corridors. And so it's not the end of the road. It may be for this particular grant program, but safety will continue regardless of Congress and anybody else. Safety will continue to be priority and will be funded. And so we're really excited about looking at how we can pay for this and do it across the county. So kind of my notes for you as you go back to your communities and your clients is to start with a real problem and not technology. I think sometimes we get bound up by, here's a great shiny new piece of technology. We have a solution, let's go find a problem to apply it to. Instead, go look for that real problem first. We already had it on Singleton Road. We knew it was there, and so we're able to take what we already knew and look for technology. So there's always great technology. Sometimes I even get caught up in, let's figure out where we can install this in the county, but we have to start with that real problem first. I think that's how you end up getting your best measure of success with this as well. So again, the big message here is that smart corridor projects, again, not just about technology, they're about building a repeatable process that your agency can use again and again. So in closing, essentially, technology is just one part of the solution. It has to be paired with a strong planning process, operations, integration, community outreach as well. It's a holistic approach, especially where you have a corridor like Singleton where not one solution is going to fix the problem. It's going to be a host of solutions, both physical construction solutions as well as technology. So that would be my message to you on this one. Again, I want to thank 360 and AECom and others who were our partners on this project. It was several years in the making. Again, we finished this project at the end of '25, and we look forward to seeing the results and tracking the data on this over the next several months and seeing where we end up with it. And so with that, I think I'll take any questions. Ah.
Thanks for the presentation, Jerry. And I was just curious about the sites chosen for like the signs. Was that really more like driven by the safety data, or was it just kind of like, another source there? And then also, like, did every location include a crosswalk, or was it like some locations without?
So at this point, we didn't build any crosswalks. We didn't build any new signals or anything like that. We essentially, we put the sensors out there and we looked at where people were crossing the road now, and it would track essentially where people are crossing and where they're trying to get to. So we then took that and we installed the beacons or the warning signs based on that data. So we didn't install them everywhere. There were a couple places we actually did not because there weren't that many people crossing the road in those locations. And the county has a project out there to put a hawk signal as well. We've looked at doing additional mid-block crossings out there, but this opportunity was, let's start with just purely technology-based and then use that to decide where we would go with actual, construction. Yes.
Hi, Gary Brady with Comsignia. One of the things that stood out to me was that you showed up front some hot spots that were targeted.
Yes.
As a planner, how would you grade the accuracy of those areas and the data that you used versus what the results showed after you got the sensors out there to actually perceive what was going on?
It's a mix, and that's because, again, the data that we had at the beginning is based on actual reported incidents. And so, you know, you figure for every incident, there's probably 100 people that cross the road in that spot as well. And so that was very important at the beginning to see where the data was showing that there actually were incidents. But once we put the sensors out there, we saw there were people crossing all over the place. And so, and again, it goes back to one of those things that we kind of knew it, we just didn't have data to back it up. And so this is the first time we actually had data to back up kind of what our internal intuition was for what was happening in that corridor.
Am I next? I guess I can ask a question. I'm over here.
Yes.
Hey, Jerry. Stephen Sheffield with Seond. And I chose my seat carefully. This way, if my question gets too technical and meanders, I can just look at Troy and hopefully he can answer. So my question is about actuation. Correct my understanding if I'm wrong, but it sounds like y'all were doing detection with technology and using the technology to know the whereabouts of pedestrians. Were you doing walk phase actuations based on the technology, or was it more just collecting information about pedestrian presence?
Troy?
No, we were not. No, so we did not integrate into the controller itself. We collected data at the crosswalks with the sensors and then utilized that from there. So the OmniSite sensor was used to collect data at those locations. And at the hotspots, we then used it as our sensor that then drove the lane light signal. So at that point, that was only a data collection and also a trigger to the sign. So, but we're not talking to the controller. We did.
When you're ready for phase 2, I have an exciting solution for you.
All right. Anybody else? Okay. All right. Thank y'all very much. All right, all you.
One second. The suspense. There it is. All right. Hey, I'm Josh. I'm with Gwinnett County, traffic signals engineer. Today I'm going to talk to you all about the implementation that we did for adaptive signal control technology on Grayson Highway. So here's the mission statement of Gwinnett County's DOT. I've underlined some important parts that I really want to focus on why we chose to do an adaptive system. Our mission statement states that the mission of Gwinnett County Department of Transportation is to enhance the quality of life by facilitating the mobility of people and goods safely and efficiently. To me, there's this quote that comes to mind from a business economist at Harvard Business School. His name was Theodore Levitt, who said, "Creativity is thinking up new things, innovation is doing new things." To me, that speaks exactly how Gwinnett County's Department of Traffic Management approaches all of our projects and approaches everything that we do for Gwinnett County. We're always trying to think of new things to do and more innovative ways to solve the problems that are in Gwinnett County. So before there was adaptive, there was planning. I'm not going to get all planny like Jerry did, but the process originally started in 2022, where we were identifying several different corridors and locations that could benefit from an adaptive signal control technology. But we had to first understand what these actual corridors needed. How good was the detection? How good was the communication? How good was the CCTV coverage for remote monitoring? What type of signal operations? Are there split phase, flashing yellow arrows, high pedestrian volumes, all these different parts that would play into how an adaptive control technology actually worked. Additionally, we had to understand what type of adaptive system was out there. What do we need? What would work for all these different corridors? And then following that, once we found the corridor, we had to develop a baseline. We had to use traditional signal timing to actually see if our adaptive control technology can improve a corridor and how well it can improve it. So we decided on Grayson Highway. Very small corridor, almost no one travels it, except for the 47,000 people that do every day. So this corridor stretches about 2.7 miles. It connects Lawrenceville to Grayson, Walton County, Rockdale County, and it sees a lot of traffic. In the morning, a lot of northbound. In the evening, a lot of southbound. They're all moving in and out. There's also a lot of turning traffic at different intersections all throughout the corridor, some in the beginning, some towards the end, some in the middle. So this is a very dynamic corridor, and it would be a great point for an adaptive signal control. Additionally, this corridor has 3 schools, Couch Middle School, Sterling Elementary, and Grayson Elementary School, all within this 2.7 miles, that all have different ingress and egress times and really do affect how the corridor operates. So we found the corridor. We asked our SIGOPS group if they could take a stab at developing a really good signal timing project to develop our baseline for this corridor. They did a fantastic job. You know, hopefully you can see the numbers. I really don't know. But they were able to decrease split failures, decrease travel time, increase AOGs, a lot of metrics that were very beneficial to Grayson Highway. Following that, we now had our baseline. We can now figure out how does adaptive operate compared to this. So here's our quick overview of the timeline of how we did deploy the adaptive signal control. In October of 2024, SWARCO was awarded the project, and they immediately began working on how they could deploy their system to our 11 traffic signals. They needed OmniEX, which is their software system, to actually be implemented onto the controllers, as well as their MyCity ATMS platform. So this meant that our team and everyone had to get used to a new server, new systems, and new software control technology. Additionally, it was then launched in July of 2025 with additional fine-tuning done in August once school happened, or came back in session. So, first step, we gotta deploy this stuff. Deploying OmniEX, we had to use our existing Q-free CPUs and Enelite controllers. The native hardware, or the native software to these controllers was not 100% compatible with how OmniEX operates. So we had to figure out how could we get our new software to work on these controllers. That took a few months, and that was fun. Very fun. But once we solved it, we're good at that. We figured it out, and we solved it, and we could keep the project moving forward. So we deployed all these in April of 2025. Each of the different intersections, there's a variety of detection systems. Some had radar, some had video, some had loops. So we also had to make sure that each of these different types of detection systems actually work with Omni and how Omni operates. The other great part of Grayson Highway is all the signals along Grayson Highway are on fiber and have awesome CCTV coverage of the entire area. So we could real-time monitor after we actually deployed Omni to these locations and make sure that what it's saying is what's happening out there in the field. So some of the other challenges we came across was after we deployed in April of 2024, GDOT began a repaving project on Grayson Highway from Walton County line to Lawrenceville. This removed several key detectors and a lot of very critical intersections for our adaptive technology, which meant we had to figure out a way to deploy redundant detection systems at these locations and make sure they actually were working correctly and were working as kind of a stopgap until those loops came back into operation. Additionally, there were 2 intersections off of State Route 20 on State Route 84 that were running off of micro-hard radios. Not the most reliable for adaptive signal. We had to upgrade these communication systems to cell and a broadband radio so we could actually have the reliable communication that we needed to run adaptive. So now the fun part, turning the sucker on. In July, we actually flipped the switch and we were go. It was a go from there. So we've done the work, we've done the prep, we've done the testing, very important. But once it actually starts in July, we have to develop that baseline. Why we chose July? School's not in session. We have already deployed all the additional detection systems that we needed. GDOT's already doing their repaving work. We could develop the baseline needed for us to do any other sort of tinkering before school actually comes into session. So how does the algorithm work? That's probably a question some of y'all have. I don't know if anyone here has ever worked with SWARCO's MyCity Adaptive, but it's essentially takes your baseline data. So we used our AM, midday, and PM timings that SIGOPS was able to create for us. And then from there, it makes choices. It either chooses to increase or decrease your cycle length, split, or alter your offset. How does it make these choices? Through the detection. That's why detection is extremely important for us. It's constantly taking in the information, and it's making choices on user-defined limits. Ours was every 2 cycles, it would make a choice to either increase or decrease certain approaches, split times, and also the cycle length and the offset. The offset is generated through the through traffic engine system that it piggybacks off of. There's a variety of different ways you could actually program that true traffic. You can program it off of detection in the roadway, or you can program it off of a designated speed, which is what we chose to do because, again, GDOT was repaving. So that's how it chooses to make its actual choices and actually run the algorithm itself. During our July fine-tuning, we came up with several different ways that we could help Swarco revamp their algorithm and make it a little bit better for a highly saturated corridor. So some of the things that they did is they took our suggestions and they were able to actually develop many ways to have their algorithm work better and also introduce new features. One of the features they introduced, which I thought was a very good feature, was you could set max limits on split times. What we noticed that would happen is because on this corridor specifically, you would have a very highly saturated movements. A left turn, side street, you name it. And what would happen is the detection would always say, I need more, and never want to give anything up, always wants more. And what would that do to our main line would actually steal more time from the main line. That wasn't really good for us. So we asked them to help relook at it and make some adjustments to their algorithm, which they did. They came back a couple of weeks later, we were able to implement it for the August, and we saw a world of difference. So, the fun part, the results. I know it's probably really hard for y'all to see back there, and I'm sorry. But this is October of 2024 and October of 2025. The red line, or orange line, can't really tell on this thing, is the later date. What we're able to see is when the adaptive system was running for an entire month, we could see that the travel time got better for the northbound, so decreased for the northbound direction by about 1% throughout the day, and for the southbound about 9%. We also were able to determine that our AOGs increased by about 5% for the northbound and about 4% for the southbound direction, which is really good considering how saturated this corridor is, especially in the evening time in the southbound direction. Again, here's a little chart on the travel time reliability. Again, I'm sorry if you can't see it that well. But what this is showing to us is that the table itself was one of the bigger pictures. It's showing that we were able to increase speed and decrease travel time by a pretty good margin for both the northbound and the southbound for the entire months of October. If y'all can't see the travel time comparison chart too well, what this is kind of showing is that the different segments along the actual project where we saw these improvements for the travel time reliability. This is a chart that I found was really interesting. I used the RIDIS GDOT 2022 data source to come up with this chart, basically comparing, again, October 2025 to October 2024. What we saw on here was a 26% decrease in user cost throughout the entire month of October. What this equivalent is about $660 an hour in savings, or approximately $10,000 for all motorists per day. Additionally, we ran another analysis in November, comparing it to the previous November, and we were able to find that that entire month we saved around $334,000 for the motorists that used this route. It is estimated that by these savings and reducing the delay, we could save people roughly $3 million a year based off of just this adaptive signal timing. It's also estimated that on this corridor, there was about a 20% increase in traffic compared to September of 2024 and September of 2025. So we had more cars, but we had better reliability for travel time, and we were able to see a reduction in user costs as well. Some of the lessons we learned. Detection is everything. For any adaptive system to work, you need reliable detection. You need more detection than what you think is even possible to put out there. You need stop bar detection for all approaches, not just your presence, your left turns or side streets. You need advanced. You need even mid-block detection to have better time arrivals and AOGs. The more you can give to any adaptive system, not just Swarco My City, the more reliable your travel times will be, the more fine-tuned your actual timings will be, and the better of a product you're going to be able to give to whoever your client or your constituents are for your project. Additionally, communication. You need a system you need a corridor that has reliable communication back to whatever type of ATMS platform you have. All these systems are taking in information second by second and taking in large amounts of information constantly. You need to have a reliable communication system that can handle all that input. You have to test. You must test your system, test it once, test it twice, and test it a third time before you implement anything inside the actual field. Last thing you want to do is stand on the middle of a street with your hands up in the air while the signal's in flash and people are honking at you. It is not a fun day. Did not ever happen, don't worry. The final step is internal training. Your team must be very comfortable. For us, we operate and maintain all of our traffic signals. That means our technicians must know the Omni database software. Our TCC staff must know the My City ATMS platform. Our engineers must know how to navigate the menus and all the other different features and all the little things throughout the entire project. That's going to be critical. If you don't know what you're looking at, you're not going to be able to solve any problems. Finally, I'd like to thank everyone who worked with us for that project. It was a lot of fun. I don't think we could have done nearly as well without everyone's support and all the countless hours that we spent. So I appreciate it all. If there's any questions or comments, be happy to answer any. It's perfect. I love it. This is, aw.
Hi, Will Ortiz, Kinley Horn. Hey, Josh. So can you provide a baseline of what the SIGOPS timing cycle lengths were initially and maybe what the average cycle lengths were while traffic responsive or this was active, just to give some sort of comparison for how much throughput this gave?
Yeah, so SIGOPS, they used a variety of timings, 160 in the morning, 150 midday, 170 in the evening. As I said, our algorithm starts with those baseline timings and baseline splits, and then we'll adjust based off that. After the updates to the algorithm and to the actual max split times were enabled, we saw that the cycle length would start roughly around the baseline. Let's just use the PM, for example, because there's a lot of stuff we could talk about. In the evening time, at about 2 o'clock, school starts getting out. We would see that the cycle lengths actually would choose anywhere between 160 to 180. So that was 10% up or 10 seconds up, 10 seconds down. What we saw is that the trend line would start at the baseline. Sometimes it would go down, depending if, Christmas time is a great example. It went down, definitely, because there wasn't any school that came out of the side streets. But what it would do is it would choose to go up in small increments of about a second, hover around the 180 during the peak hour. So from about 4:30 to about 6:30 or so, it would hover around the 180s, flush out as much traffic as it could, and then we would see it start decreasing and cycling down. So as far as the average cycle length it gave, I can't really tell you. It changes daily. But what we did notice is that it actually moved with the traffic and then would go down with the traffic, which is what you want your adaptive system to do. Does that answer your question?
Yeah, that's perfect. I just want to make sure, was it running 250s or something crazy,
No,
to make this look so great. So that's good to hear. Thank you.
Yeah. Any other questions? Look what you started, Will.
Hey, Susan Jin with Atkins Reales. So as a fellow Gwinnettian, it's very exciting that you solved the directional traffic problem on one of the major corridors. So is there any plans for implementing this technology elsewhere in the county?
So as of right now, there isn't. We're still watching and looking and trying to learn. Adaptive is a very tough bird. As I said, it depends on your project location. So the reason also why we chose this section of Grayson Highway is there's no cross coordination. There's no other major system that cuts through any of the other signals. Once that happens, now you're having a different type of issue that you have to solve.
Julie Doyle with Thomas & Hutton. Was there an impact on crashes, severity, frequency, type, anything like that?
So far, no. Actually, in I believe October or September, there was a vehicle wreck, a minor one, near WebGen, and we actually got to see how our adaptive system responded to that type of incident that happens. Obviously, it's a non-recurring event. You know, what's it going to do? And we saw that our adaptive system started to help push the traffic without us manually having to override our traffic signal operations or actually change anything in itself. But as far as any type of safety benefits, we haven't really seen any of that yet. I'm sure after a year or so we can pull that data and see. All right. Oh.
You didn't talk about budget.
Budget's endless.
How much did this cost?
Budget-wise, I believe it was $1 million that we budgeted for this actual program. We ended up spending less than that, luckily, which helped out a lot. When GDOT started ripping up the loops, we were able to actually use our budget to help replace the detection system. So I did have a little, it's estimate that we could see a BC of about 3 for this project, especially for saving $3 million annually, and it only costs us less than $1 million to implement the system. But again, I haven't actually ran those numbers, so it's all just approximate. Any other questions? Going once, twice, sold. Awesome.
Okay, thank you to our speakers. Let's do another round of applause really quick. And that is it for us, you guys. Hopefully we'll see you in Charlotte for the summit in March, and then our next meeting is in April at Sandy Springs. Be safe. Thank you, everyone.